Now let's do a few that have some trig functions in them. You know, it's just the same stuff. As long as you know your trig functions, you're set. Again, we're going to take a look at thinking about undoing the chain rule, the inside function and the outside function. And so for this one, again, we have one choice. We could choose the 1 plus cosine t bit as our u or our sine as our u. But what we really want to choose is the 1 plus cosine t. Why? Because that's inside the square root. So the square root again becomes a power, is a power. So if I want, I can rewrite this like this. Think about that as a power function, and the inside function of the power function is this 1 plus cosine t. And I know that when I take the derivative of the chain rule of that, I'm going to have to take the derivative of the inside, and that's going to give me that extra sine t. So that kind of makes me think I'm undoing the chain rule, something that I took the derivative of. Let's do it. So du dt here, derivative of cosine is negative sine. So I just have to track this a second. Um, I'm going to want negative, I'm going to do it right here. Negative du is sine t dt. And that is exactly what I have here, sine t dt, right? So once I have that, I can substitute this back in. I'm going to have u to the 1/2 and sine t dt is going to give me a negative du. I'm going to throw my negative out front. I have to be careful so the negative's clear. You have to match these guys so we get the right answer. Okay, so this is an easy, once I've got it in this form, this is an easy integral. Make sure that you see where everything comes from, where the u became cosine t and all that stuff. Um, what became 1 plus cosine t, my bad. And then what do? We just use the regular old power rule to take the antiderivative. So it's going to be u to the n plus 1 over n plus 1. So I'm going to have a u to the 3/2 over 3/2, which I'm just going to write it like that. Nice, right? And then I end up with my answer. I'm going to do these a little bit bigger here. So negative 2/3 1 plus cosine t to the 3/2 plus c. And you'll see if I take the derivative of that, I should get what my original integrand was because the 3/2 and the 2/3 cancel out. And the minus there will cancel out from when I take the derivative of the cosine. So all we need to do, make sure we know all of our trig derivatives really well. And these will come in pretty handy. Again, trig functions. Similar to another one we did, there's two functions sitting around here, secant and tangent. Maybe I have, which one's the best one to choose for my U sub? I don't know. Well, I do know, but let's think about it. Because it could be tangent or it could be secant. In order to figure out the right choice, we have to know what the derivatives are. So if I know that the derivative of tangent is secant squared, and I know, oops, dx, don't forget your dx, if I know that the derivative of secant is secant tangent, and then I look at those possibilities and look at my integrand, I can sort of see that this has maybe a little bit too many secants and the tangents in the wrong place. Whereas this guy, that secant squared is really there nicely on that top. It's just right there. That is right there. It's the same thing I have here. And then yeah, I have tangent squared in the bottom, but that's not a problem for me, right? So this is the one I want to choose. If I tried to substitute in that, I could try to do something, but it looks like it would be kind of a mess. So it really helped me though to know what those forms are, because then you kind of don't have to go through the process of writing them both down and thinking about it. Like just think about it in your head. You're like, oh, I can see. I know that the derivative of tangent is secant squared. So that I want to make my tangent my u so that I get a du. And I exactly get that, right? Because the whole top, the secant squared x dx, that whole thing is du. Now it's just easy, right? Because this is just minus 2 to the minus 1. All right, well, I can say what? I know. Let's do it. Let's do it a little bit more carefully. So then I have u to the minus 1 over minus 1, right? Because I'm doing n plus 1, so it'd be minus 2 plus 1. So this is just minus 1 over u. But what was u? This u is tangent x. Okay, so that's cool. You can leave it that way. But you can also make it, sorry, cotangent x if you want, right? So because the reciprocal of tangent is cotangent. Okay. So wait, what happened here? Let's just be very clear. It would be minus 1 over u plus c, and our u was tangent x. Okay. So most of them are kind of like that, but they can get a little bit more difficult. This one is one where we might have to do a little bit of working with that stuff with our trig functions in order to get the answer here. Because you look at this and immediately you would say, I know I have an inside function, outside function, square root, whatever's under the square root, I really want that to be my u, right? So if I do that, that's great, but my du is going to be secant squared. All right, secant squared dt. And I'm like, wait a minute, there's no secant in there, but there's a cosine. But then I have to remember, if I know my trig functions well, I know immediately, notice that secant squared is 1 over cosine squared. So I can rewrite this guy as dt over cosine squared. Or I could go back and rewrite this with the secant, whatever I want to do, right? So if I know my trig identities and my trig functions well enough, these problems, which look very difficult sometimes, can really pop out pretty easily. But you do have to remember that secant is the reciprocal of cosine, etc. So let's do that. Let's just go with what we did. Let me rewrite it a little bit so it's a little bit clearer. We can write it as dt over cosine squared t and 1 over the square root of 1 plus tangent t. And then you can see that this is just 1 over square root of u du. I know there's a lot of square roots in these problems. So well, that's just what it is, I guess. You do have a lot of square roots. It didn't have to be a square root. It could have been a power to this, could have been squared or to the 10th or whatever. It would be the same principle. Okay, so we know what this is. This is u to the negative 1/2. So this is just u to the 1/2 over 1/2. And then that gives us what we want. Square root here, 1 plus tangent t with our plus c at the end. Okay. But without remembering, like you see, we have to remember our derivatives and we have to remember our, basic trig identities, like not some sort of crazy identity, but just like the basics. One more? Do I have one more? Yeah, we just did 3, so that's good. We'll just stop there and do the next one later.